In this video, I'd like to talk about determining the domain of different functions. So with the domain, remember domain deals specifically with your independent variable. So usually the x value, but basically whatever goes inside your function, that's your independent variable, and domain just deals with which values of that independent variable can actually be put inside this function. And with the domain, there's essentially two key issues that we have to concern ourselves with. So let me write that down. So two, we'll say issues with domain. And the first one is division by zero. So one, you cannot divide by zero. And I've talked about that in other videos, but basically you can't do division by zero because we cannot assign a value for that. So you could make an argument that, let's say you have 2 divided by 0. You can make an argument that this is equal to infinity. But you can also make the argument that this is equal to minus infinity. And since you can make an equally valid argument that it's equal to these two completely opposite ideas, there's no way we can pick one of them. And so we just say that this is undefined. And so that's one of the key issues we have to concern ourselves with. We can't divide by 0. So if you're ever dividing by x in your function, you have to be careful about which x values would actually make the denominator 0. Now the second issue, and that's actually going to concern this problem, is square roots of negative numbers. Or in other words, imaginary numbers. So if we had like the square root of -1, which we give the letter I, this is not something that we'd consider in the domain because we can't graph this on the standard xy coordinate plane, since this xy coordinate plane deals strictly with real numbers, just the normal everyday numbers, not these imaginary numbers. Now there are ways to graph imaginary numbers, but they're way more advanced than a typical high school class. So at least when you first learn about domain, you kind of just omit these imaginary numbers because you can't graph them. So when dealing with the domain, one way to phrase it is which values of the independent variable, or which values of x, can actually be graphed. And so with all of this in mind, with these two distinct issues we have to be careful for, we can start working on this problem. And notice this has a square root in it. So we're going to be looking at this second issue here. We don't want to have square roots of negative numbers. So the general idea, let me make a little bit more room, is that when you're dealing with a square root, like let's say we have f of x is the square root of x, you want to say that everything under the square root has to be positive. So for this simple example, we just say that x has to be bigger than or equal to 0. And it's important to include the equal sign, because if you do plug in x equals 0, you just get the square root of 0, and what number multiplied by itself gives you 0, and that would just be 0. So you can actually get a value. In fact, this would go through the point 0, 0. That's essentially its starting point, because any x value to the left of that, like negative 0.001, would give you an imaginary number, and you wouldn't be able to graph that. So whatever is underneath the square root, we're just going to say that expression has to be bigger than or equal to 0. So we'll do the same thing with our g of x here. So let me just rewrite it. All we have to do is say that whatever is under the square root is either 0 or bigger. And I'll just write that. Because the square root underneath it, it has to be a positive number. Otherwise, you're dealing with these imaginary numbers which you can't graph. So we'll say this whole expression, x plus 3, is bigger than or equal to 0. And from here, you can just solve for x. So we just subtract 3 on each side, and you get that x is bigger than or equal to -3. So this is our domain, and we can answer the multiple choice in a moment, but it should make sense to you. Because if you plug in -3 here, you just get the square root of 0, which is okay. We verified that that is a valid point that we can graph. But if you plug in anything less than that, like let's say -4, then you would get the square root of -1, which is imaginary, and you can't graph that. But if you plug in values bigger than minus 3, like let's say minus 2 or 1 or 100, you would end up with a positive value in your square root. In this case, you would get the square root of 1, which is just 1. And so we can actually plot that point. That would be at minus 2 comma 1. So that's the general idea. We've found this domain, so let's see if we can find the answers. So all real values of x such that x can't be minus 3. Well, x can be minus 3, so that's not right. And then this is all real values of x such that x is bigger than or equal to minus 3, which is exactly what we found. So that one's right. And you can go through and check that the rest of them are wrong as well, just to make sure. But this is when x can't be 3. Well, x can be 3. That would be perfectly valid. That's just the square root of 6. And this one, it's just missing the negative sign. And this isn't true because a value like minus 2, minus 1, 0, 1, and 2 all work. So that's not right. And then it's definitely not all values of x because it can't be anything less than minus 3. If it's minus 5, you're going to get imaginary numbers, and we just can't graph that on our coordinate plane. So not that as well. Now, you don't have to go through this process. Once you find an answer, you can just select that one. But if you're taking a test, it's probably a good idea just to verify this, especially if you have extra time. So with that in mind, let's start working on the next one. And we have this function g of x. I'm just going to rewrite it over here, but it's 5 minus 2x, which you might recognize as a linear equation. In fact, this could be rewritten as minus 2x plus 5, and comparing it to our slope-intercept form, we could actually graph this line. The slope is minus 2, and the y-intercept is positive 5. And the reason I'm kind of going through all this is sometimes it does help to have a visual. So that's a very rough coordinate plane. It goes through a positive 5 as a slope of minus 2. So it's going to look something like this. But the main purpose of drawing this is so that you can see that for any x value you can imagine plugging in, there is a corresponding y value. So every x value can actually be graphed. And one other way to think about this is that this function does not have any division by x, so we don't have to worry about dividing by 0. And it also doesn't have a square root, so we don't have to worry about imaginary numbers. And if a function does not have division by some x expression, maybe, just so you have an idea of what I'm talking about, maybe something like 3 over x plus 4, it doesn't have anything like this where the x is in the denominator, and it doesn't have a square root. And since it doesn't have either of those two issues, we can assume that every single x value will work in this domain. There's no x value that can't be graphed. And you can see that visually with this line here. Every x value you can imagine, you can plug into this and you will get a y value, and then you will be able to graph that coordinate point. So in this case, it's actually e, all real values of x, that will work. Notice these are all wrong because each of these has a restriction. Some value of x that they're not allowing, or maybe infinitely many values of x that they're not allowing.